Solving equations using multiplication and division. This is a follow-up lesson off of the solving equations using addition and subtraction. This is a very similar lesson. We will start by looking at a similar problem that we did on the other lesson that has to do with the blocks and the circles. If you look at the 2 blocks on the left and the 4 blocks on the right, you may already be able to see how much one maroon block is worth. However, how do we come across this solution? By using logic. Well, on the left side we have an even number of blocks, 2 blocks. On the right side we have an even number of circles, 4 circles. So if we were to want to just find one block, well, what we would need to do is make sure we do the same thing to both sides and get rid of half as many of the blocks. If we get rid of half of the blocks on the left, then we have to half the expression on the right. Well, what's half of 4? Just 2. So that keeps our balance balanced by just taking half of each side, and it brings us down to a single block of 1 and 2 circles being our solution. A similar problem is if we have one like this. That is half of a maroon block on the left, and on the right side we have 4 blue circles. So similarly, if we only have half as many blocks and we want to know the value of one whole block, well, we would have to take 2 of those halves to create 1. So we would double this side, the left side, and if we doubled the left side, we would have to double the right side, thus giving us a solution that 1 whole square is equal to 8 circles. So using that logic, if we were to write this as an equation, this would be half of an unknown value right now is equal to 4 blue circles. Well, how do we figure out what that unknown value is? Well, like I said with the previous problem, we have to double both sides to get us to a full 1 whole. So if we doubled both sides, that gives us a whole value of x and 8 on the right side. That is what it would look like algebraically. So let's look at some examples. Just like in the addition and subtraction, if you multiply or divide on one side of the equation, make sure you do the same to the other side. Our goal is to isolate that variable by using the inverse operation. So the first one, 7x equals 21. Right now we have 7 maroon boxes on the left and 21 circles on the right. How can we partition this up to only get one of those x's? Well, we need to divide it. If we have multiplication 7 times x, we need to do the opposite of multiplication, the inverse, which is to divide by 7. Again, if I do it to one side, I need to do it to the other side. So if I divide by 7 on the left, that reduces to a 1. I want to make sure you realize that's 7 divided by 7 is 1 times x, not 0, equals 3. And we all know that 1 times anything is just that value. So that gives us x equals 3. So again, we're not canceling that 7, we're simplifying it to a 1. On the right side, this is a problem where kids really struggle. They see that negative and they automatically want to divide, or they automatically want to add 5 to both sides. You cannot add 5 in this case. The reason is because you have to understand what operation is happening to the variable. The operation, and if you don't know what an operation is, I have had to review this a little bit. An operation is addition, subtraction, multiplication, division. An operation is anything that you're doing to some numbers. So squaring, square rooting, those are operations. But these are the main 4: adding, subtracting, multiplication, and division. What is the operation that is happening to the y variable? Right now we are multiplying by a -5. So you need to undo the operation happening to the variable. So if we undo multiplication again, we need to divide. Now a lot of kids will just say, oh, I'll just divide by 5, but no, that'll give us a negative 1 at the end. We don't want a negative 1, we want 1. So you need to make sure you divide by the exact same thing. No matter what it is, divide by the exact same value on top and bottom. Do it to both sides because we got to keep our balance balanced. And negative 5 divided by negative 5 gives me a 1. So again, 1 times y is y. Now when you divide by a negative, our answer will become negative, and 25 divided by 5 is 5. Now, clarifying, when you divide by that negative, the reason it becomes negative is because the top is positive. If it happened to be a negative 25, then it becomes a positive because negative times or divided by a negative is a positive. So just be careful and remember those rules with the negatives of division and multiplication. Moving on to a couple other examples. Division problems. If you have some value n divided by 6, you need to do the opposite of that. How do you undo division by 6? Well, you need to multiply by 6. Again, that gives us this value of 6 over 6, which we all know is 1. So this becomes n equals 18. So you may see a pattern. Your goal is to get any number in front of your variable to be equal to 1. If you can get that value in front of the variable or with the variable to equal 1 in a multiplication or division problem, then that will isolate the variable. In the problem below that, x divided by negative 2 equals 5. Same type of problem. You're going to want to multiply both sides because you are dividing. So you do the inverse of what's happening to the variable. So instead of dividing by negative 2, we're going to multiply by negative 2 to both sides. That will reduce that to a 1. So that gives us x equals, and 5 times negative 2 is negative 10. I just want to introduce a problem that you may see, not the top one, but the bottom one. This 6 divided by n equals 3. That is actually a little bit more complicated of a problem. It is doable, but it's not by doing the steps that you may think you need to do. In this problem, you might think, oh, just divide by 6, that'll get rid of the 6, and I'm done. No, that's not the case here, because if you do that, the n will still be in the denominator. There is a way to solve this problem, but we're going to work on that later. That is it. That is your lesson on multiplying and dividing to solve equations. Good luck.